This object is simply a piece of another solar system that was expelled, and it has been traveling through interstellar space for hundreds of millions of years, billions of years, we don't know.
And found that this interstellar object has gained an unexpected boost of speed.
One-eye Oumuamua was a relatively small celestial object that originated from interstellar space and made a close pass by the Sun as it traversed the inner regions of our solar system in the autumn of 2017. Its significance lay in being the first confirmed object to have originated from a planetary system outside of our own. Now it has once again grabbed the attention of the scientific community. NASA has announced the return of Oumuamua, but this time it is not alone on its cosmic journey. According to NASA, the object's concealed characteristics hold an intriguing clue about the potential for life in other star systems. This is not a typical reappearance of a celestial body. It represents a return that challenges our comprehension of space and the potential existence of extraterrestrial life. Join us as we delve into the implications and enigmas surrounding the unexpected return of Oumuamua. Astronomers had been anticipating the arrival of an interstellar object like Oumuamua for a considerable time. For decades, we've theorized that such interstellar objects are out there, and now, for the first time, we have direct evidence they exist, remarked Thomas Zurbuchen, who was NASA's Associate Administrator for Science when Oumuamua was discovered in 2017. Then, in August 2019, another interstellar object named 2I Borisov entered our solar system. However, Borisov exhibited characteristics typical of a comet, including a coma, the gaseous head surrounding a comet's icy core, and a tail. In stark contrast, Oumuamua stood out due to its lack of a coma or tail. The revelation of Oumuamua's presence prompted a worldwide effort to observe the object through telescopes. Astronomers, including those affiliated with the SETI Institute, eagerly observed Oumuamua and even initiated searches for potential extraterrestrial signals. Oumuamua appeared as a reddish, elongated object with a cigar-like shape composed of rock. Its elongated form was particularly striking, measuring up to 1/4 mile in length and about 10 times longer than its width. Oumuamua possessed an aspect ratio that exceeded that of any asteroid or comet ever observed within our solar system. Furthermore, Oumuamua was traveling at an astonishing speed of 196,000 miles per hour as it approached Earth, which is 110 times faster than a bullet. This velocity ruled out the possibility of Oumuamua originating from within our solar system, as it had to be an interstellar visitor. Initially, scientists grappled with classifying Oumuamua, uncertain whether it belonged to the category of asteroids or comets. To differentiate between the two, it's important to note that comets primarily consist of ice, while asteroids are composed of rock. Initially, Oumuamua was thought to be a comet, but this classification shifted to asteroid when it passed close to the Sun on September 9, 2017. However, it was later reconsidered as a comet when additional measurements revealed a slight acceleration, a characteristic often associated with comets. What truly puzzled scientists was the extent of Oumuamua's acceleration, which far exceeded their predictions. Another intriguing aspect of Oumuamua was its periodic brightening and dimming, occurring every 7.3 hours, indicating rotation around its short axis. This rotational pattern suggested a more robust and solid composition compared to the typically fragile, snow-like materials found on most comets. The object's reddish hue, akin to certain moons in the outer reaches of our solar system influenced by space radiation, suggested the presence of iron, as suggested by Dr. Meach, an astronomer at the University of Hawaii's Institute. Despite these insights, Oumuamua's origin and characteristics remain an enigma. Its trajectory baffled scientists, hinting at phenomena that transcend conventional natural explanations. This led to the emergence of various theories regarding Oumuamua's identity. While some posited that it was a rock, others proposed a gaseous composition. Remarkably, a subset of experts even entertained the notion that it might be an alien spacecraft. This tantalizing idea raises the question of whether an extraterrestrial mothership could be navigating our solar system, deploying smaller probes to explore celestial bodies. The scientific community has proposed a wide array of hypotheses to unravel the origins of Oumuamua. Dr. Meach suggested that it might have been ejected from a distant star following a supernova explosion, or possibly formed through the collision and fusion of two celestial objects. Initially, astronomers were intrigued when they observed Oumuamua's trajectory seemingly pointing towards Vega, the brightest star in the Lyra constellation, known to possess a debris disk. Calculations indicated that this object could have traversed from Vega to our vicinity in approximately 600,000 years. However, the likelihood of Vega being the exact source has diminished due to substantial alterations in Oumuamua's path. Considering its motion around the Sun, similar to the velocity of nearby stars, it is believed that Oumuamua encountered a new star system for the first time. Nevertheless, there's a possibility, as proposed in nature, that Oumuamua might have been journeying through the galaxy for billions of years. Its future trajectory remains uncertain. To illustrate, think about how the Voyager spacecraft gained speed from Jupiter's gravitational assist. Similarly, Oumuamua is accelerating due to the Sun's influence, propelling it at a greater speed and in a different direction. Dr. Meach explained that this asteroid, along with others like it, revolutionizes our perspective of the galaxy. Consider this. When we gaze at seemingly distant and isolated stars, it contrasts with what these asteroids reveal. They remind us of the interconnectedness and intrigue of the universe. The oxygen and iron in our blood, for instance, originated from a massive explosion in a distant cosmic locale. The gold found in items like wedding rings resulted from the collision of superdense stars. Even the meteorites that occasionally strike Earth, some of them potentially originating from Mars due to asteroid impacts, have fascinating implications. Some esteemed scientists even contemplate the possibility that these meteorites could have transported life from Mars to Earth during a period when Mars had hospitable warm and wet conditions. This theory suggests that life might have originated on Mars and then hitchhiked on these meteorites to Earth, a bold concept that is still being pondered by astronomers. Our connection to the cosmos has deep roots that extend even further into the past. Consider the hundreds of thousands of years it might have taken Oumuamua to reach our solar system. While this time frame may seem lengthy from a human perspective, it's but a fleeting moment on the cosmic timescale. The Milky Way galaxy itself has an age of around 10 billion years. Over this immense expanse of time, Oumuamua could have journeyed through approximately 20,000 star systems. While this number represents a modest fraction compared to the galaxy's vast count of 200 billion stars, it still signifies a significant series of cosmic encounters. As Oumuamua traversed the galaxy, it likely trailed behind dust and debris, facilitating the mingling of stars and worlds throughout the universe. This intriguing concept hints that the universe might be more interconnected and smaller in scope than previously imagined. Even though Oumuamua is no longer within our immediate view, it appears that the solar system hasn't entirely released its grasp on this enigmatic interstellar traveller. The path of Oumuamua has been meticulously traced back to a period before its initial entry into our solar system, thanks to the work of Corinne Baylor-Jones from the Max Planck Institute for Astronomy. This involved comparing Oumuamua's trajectory to the historical positions of 7 million stars that have been tracked by the Gaia spacecraft. By rewinding both Oumuamua's path and the orbits of these stars, potential points of overlap were identified. Among the stars whose trajectories closely approached Oumuamua's rewound path, 4 candidates emerged as possible contenders for its home. According to NASA, Oumuamua's course intersected within a range of 1 to 2 Oort cloud radii, equivalent to 100,000 to 200,000 astronomical units (AU), while Baylor-Jones conducted this analysis. However, there were complications to consider. The encounter velocities of these potential candidate stars were relatively high, ranging from about 6 to 16 meters per second. This raised a potential issue since Oumuamua is believed to be a planetesimal, a remnant from the early stages of planetary formation. It's unusual for planetesimals to attain such high ejection velocities solely through interactions with large planets. Our predictions would have suggested velocities of just a few miles per second. While these high velocities are not impossible, they are considered quite unlikely. The scenario becomes more plausible if Oumuamua originated in a binary star system. However, none of the 4 candidate stars were identified as binary stars. Naturally, future data releases from the Gaia mission may provide astronomers with additional information to pinpoint a more suitable source for Oumuamua by offering deeper insights into the motions of nearby stars. It would be fascinating to revisit this analysis in a few years, given the limited data currently available. Meanwhile, some astronomers have entertained the idea that Oumuamua might have extraterrestrial origin, further deepening the mystery. A preliminary article authored by a Harvard scientist and the head of the Pentagon's UFO office has raised the possibility of an extraterrestrial mothership's presence within our solar system. This hypothetical mothership could hypothetically dispatch tiny probes, similar to dandelion seeds, to explore various planets. The disclosure of this document was made by Sean Kirkpatrick, who directs the Pentagon's All-Domain Anomaly Resolution Office, AARO, established in July 2022 by the Department of Defense to identify and investigate intriguing objects. Avi Loeb, an astronomer at Harvard University, collaborated on this draft study with the Department of Defense. It's worth noting that the study does not carry the official endorsement of the Pentagon. Loeb is well known for his research on Oumuamua, and he has even proposed the idea that Oumuamua might be an extraterrestrial spacecraft. 6 months prior to Oumuamua's close encounter with Earth, our planet experienced the impact of a small interstellar meteor measuring about 3 feet in diameter. While unrelated to Oumuamua, this meteor, known as IM2, piqued Loeb's interest. Serendipitously, Loeb considered the possibility that an artificial interstellar object could serve as a parent craft, releasing numerous small probes during its passage near Earth, a concept somewhat akin to NASA's spacecraft missions. The gravitational forces exerted by the Sun, or the craft's propulsion system, could hypothetically detach these dandelion seed-like probes from their parent vessel. In their preliminary study, Loeb and Kirkpatrick delved into unidentified anomalous phenomena, UAPs. While staying within the bounds of established physics, these scientists proposed that the dandelion seed-like probes might make their way to Earth for observation without being easily detectable by survey telescopes. This invisibility could be due to their small size, which would limit their reflection of sunlight. According to their hypotheses, the technology of these probes might allow them to decelerate within Earth's atmosphere, preventing them from burning up. They could then deploy parachute-like features to navigate to their intended destinations once they land. The speculation is that advanced alien civilizations might have an interest in studying rocky planets with atmospheres in our solar system, particularly planets like Venus, Earth, and Mars, which exhibit signs of liquid water. Importantly, the mothership wouldn't necessarily need to house the advanced extraterrestrial civilization responsible for creating the probes. And until recently, it was widely believed that Oumuamua was on a trajectory out of our solar system, with an expected entry into interstellar space by 2030. However, there are indications that Oumuamua is altering its course once more. While researchers have confirmed its presence near Neptune, there is a lingering concern that this object might eventually return to Earth due to its peculiar orbital behavior. If such an event were to occur, it could lead to various potential outcomes. It's essential to avoid presuming that Oumuamua couldn't reach Earth after traveling such vast distances. We still lack precise knowledge about the true nature of this object and the extent of its capabilities.